Good evening. We're going to be talking about electromagnetic radiation. So, what exactly is electromagnetic radiation? Electromagnetic radiation is the form taken by energy as it travels through space. So, you've probably heard of radio waves, microwaves, infrared radiation, gamma, X-ray, and all those. So electromagnetic radiation is simply the form that energy takes as it travels through space. You're probably already familiar with some of the uses of these electromagnetic radiation forms, but we'll talk about more in this video. So stay tuned up to the end. The form of energy in space have differences and similarities. So if we talk about the radio waves and the microwaves, these two are not exactly the same. They have their differences as well. And so is the same case with every one of these. Like they're different from each other in a way too that we'll talk about. All electromagnetic radiation forms are transverse waves. So when we talk about the radio waves, the microwaves, infrared, visible light, all those in the series are transverse waves. Now, what is a transverse wave? It turns out that a transverse wave is a wave whose direction of propagation is perpendicular to its points. So when we consider the crests over here and the troughs, the crest is the upper point of the wave and the trough is the lower point. When we consider these, notice that the point over there is at right angles to the direction of propagation, which is this line here. And so to talk about transverse wave a bit more, just so we're clear, if we have this as the path taken by a wave and we have a wave in here, then the top part of the wave is going to be called the crest, and then the bottommost part will be the trough. Now the distance between two successive points of the same nature, such as from crest to crest or from trough to trough, that's called a wavelength. So a wavelength is simply the distance between two similar points in a wave. Well, that's for a transverse wave at least. There's the other type of wave called longitudinal wave, but we're not going to talk about that in this video because our focus is on the electromagnetic waves, which are all transverse in nature. Now, a wave would start from a point such as this one. It makes it complete, it makes half a turn and makes another turn over the bottom. So from this part here, this portion of the wave to over there, that's what we call a complete wave or a complete cycle. So in here there's 1, 2, and 3 wave cycles. So those are the basics. And one more thing, there's amplitude here. So amplitude is the displacement of the wave from its initial position to its maximum or to its minimum point. Other examples of transverse waves include water waves. When you throw a stone into a water container, the water happens to form such a wave. Or when you tie a string to a fixed end and then move the string in an up and down motion continuously, it's also going to form such a wave. All electromagnetic waves have different wavelengths and frequencies, but what's more interesting is that they all travel at the same speed, which is the speed of light, 3.00 multiplied by 10 to the power 8 meters per second. But here in chemistry, you might want to remember 3.00 times 10 to the power 17 nanometers per second. That is because mostly when we do calculations, the wavelength will be expressed in nanometers. The wavelength, as we deal with light, is too small to be expressed in meters. So you would want to remember the 3.00 times 10 to the power 17. It's actually the same, except it's converted to nanometers per second. Now, frequency is the number of waves that pass through a point in 1 second. Light waves are very, very fast waves. They travel at very high speed. So in 1 second, it happens that there are a lot of waves that pass through a certain point, and that's what we call the frequency. But in the electromagnetic spectrum, where we have the radio waves, microwaves, infrared radiation, visible light, ultraviolet, the X and gamma rays. The gamma rays are the ones with the highest frequency, but we'll talk about that later in this video. So if you happen to like my channel and the content that I'm making, please subscribe, like, and keep watching my videos. And you can always email me at the email address I'll provide at the end of this video. Wavelength is a distance between two successive crests or troughs, as discussed earlier on. So from crest to crest or from trough to trough, that's called wavelength. It can be in meters or in nanometers, any unit of length, but for convenience we use the nanometers and the meter instead of any other units like the centimeter. That would be confusing. And amplitude is a distance between the peak, which could be the crest or could be the trough. The crest is the maximum point on a wave, and the trough is the depression in a transverse wave. So the amplitude is simply the distance from the origin of the wave up to as far high or as far low as it can go. These are the types of electromagnetic radiation that we've been talking about, and it starts from radio waves, there's microwaves here, infrared, and there's visible light, ultraviolet radiation, X-rays, and gamma. And all these have different uses, so you can pause the video and look into them. They are actually quite interesting, but for this video we're not going to talk about those. But what's interesting to know is, from the left towards the right, the frequency of these waves increases. So gamma happens to have the highest frequency out of all these 7. And from right to left, we have increasing wavelength, which means the radio waves have the highest wavelength. Now, what you should know about these two is that frequency and wavelength, they are inversely proportional. So when one increases, the other one decreases. And this is so because the speed at which they travel is the same. So if one increases, the other one must decrease in order to not affect the equation. Now, since the speed of any object, according to physics, we define that to be the speed is equal to distance divided by the time taken. Now, for light or any of those electromagnetic radiation forms, we say speed of light is equal to the wavelength, which is represented by the Greek letter lowercase lambda, and multiplied by frequency, which is lowercase nu in the Greek alphabet. Now you might be wondering why we are multiplying here instead of dividing, but actually the frequency is simply an inverse of time. So it's the same as wavelength divided by time taken. But we'd rather just use the frequency, since frequency is a property of waves. And the unity for frequency is the hertz or the per second. The units for wavelength, we already discussed that earlier on. It's nanometers or it's in meters, depending on what unit we use for the speed of light, whether meters per second or nanometers per second. Ultimately, the equation is C equals lambda multiplied by nu, which is basically speed of light equals the wavelength multiplied by the frequency of the wave. So I'm so grateful. Thank you very much for watching till the end. If you like my content, please subscribe to this channel, like my Facebook page on Captain Tutorials, and share. Please stay glued. Now, on this channel, I'll be posting more videos on physics, chemistry, biology, mathematics, so that should be helpful. And what I ask of you is to simply stay tuned, subscribe, and click the bell icon so you can see my videos as soon as I upload them. Thank you very much for watching, and have a great day.